Hi, Mr. Sapone here, and today we're going to be talking about moles. You can see an image over here. Hey, ladies, take my number. I actually have this outside my door as a meme. And the reason is this number right here is extremely important in chemistry. It's called Avogadro's number, and this, of course, is Avogadro, the scientist who it is named after. 6.022 times 10 to the 23rd. And we're going to talk about what moles mean. A mole in chemistry is not to be confused with this very happy individual who is a mole, or those things you get on your face. A mole is simply going to be really this number. And we're going to talk about what that means. A mole is defined as 6.022 times 10 to the 23rd particles of a substance. And this very special number is, as noted, Avogadro's. And I know, like, what do you mean a mole is 6.022? Well, think about a dozen. If you had a dozen pencils, how many pencils would you have? You would have 12. If I assigned you a dozen detentions, how many detentions would you have? 12. If you had a dozen marshmallows, you would have 12 marshmallows. The word dozen means 12. Well, the word mole means a much, much bigger number. It just means 6.022 times 10 to the 23rd. So mole always equals that number of particles with whatever we're talking about, whether it's molecules, atoms, or, I don't know, fluffy kittens. If you had a mole of kittens, you would have 6.022 times 10 to the 23rd kittens, which are certainly more kittens than there are on the Earth by far. So dozen means 12, mole means that number. And we're going to see what this number means and why it's very important in chemistry. Atoms are too small to count, so we're going to use moles in chemical reactions, and essentially we are going to use mass as a means of counting. But when we want to create something new in a chemical reaction, we need to know how much to mix together to yield what we want. And chemical reactions get very complicated. When you're in a lab, you don't want to have excess ingredients. You want to be cost effective. You don't want to have to worry about side reactions occurring, putting too much of one thing or not enough of it. So we need to know exactly what to put in and how much of each quantity when we're manufacturing or building things. And take this equation right here. This is a very simple combination or combustion reaction. 2Mg plus O2 yields 2MgO. This is really the combustion of magnesium. It's what happened when we burned magnesium coil. We got that intense, bright, white light, a very exothermic reaction. There's several ways you could read this, but we're going to talk about moles now. So when we read chemical formulas, I want to read them in terms of moles. So this is saying 2 moles of magnesium is combining with 1 mole. The 1 is assumed if it's not there. 1 mole of diatomic oxygen to yield, the arrow's the yield sign, 2 moles of magnesium oxide. So we're going to read chemical equations in terms of moles. And we're going to do that because we can't count atoms, they're too small, but we're going to use moles, which convert to grams very easily, as we're going to see. We're going to use moles as a mass. Our moles use mass really as a means of counting atoms. We're going to count atoms by essentially getting their mass on a scale. So we have here iron. This is a periodic table box for iron, Fe. And the atomic mass, the weighted average of all the isotopes of iron, is 55.85 AMUs. This number also represents the molar mass of iron. Not only the atomic mass, but the molar mass. Iron has a molar mass of 55.85. And this means 1 mole of iron, and 1 mole of iron will be this many atoms of iron. Remember the definition of a mole? 6.022 times 10 to the 23rd unit. So if you had a mole of iron, you'd have this many atoms of iron all in a pile. And we certainly can't draw that many, but you'd have this many atoms. And what we're saying is it would weigh 55.85 grams. So this number on the bottom of the periodic table has a dual purpose. It's not just atomic mass. It is the molar mass, or as sometimes called the formula mass or the formula weight. I'm not too fond of the term molecular mass for reasons I won't get into right now. But 1 mole of anything is this many particles. And this right here is how much 1 mole of iron will weigh. This bottom number on the periodic table is the molar mass. It tells me that there's 55.85 grams per mole. So this many atoms of iron will weigh 55.85 grams. And again, the unit is grams per mole. And this not only applies to iron, but to every element on the periodic table. This bottom number is the molar mass, or formula mass. So let's look at some atoms. What is the molar mass of gold? Well, again, it's the bottom number, so it's going to be 196.97 or rounded to 197. Don't forget the grams per mole. And how about mercury? Mercury is going to be 200.59. That's the molar mass of mercury. Silver, 107.9. Oxygen, you might think it's going to be 16. That's not going to turn out correct. And hydrogen, I believe we skipped sulfur because I didn't have enough room for the other box. But gold is 197 rounded. Mercury is 200.6 rounded. Silver, that is incorrect. That's not silver. So, a little boo-boo there. Oxygen. Oxygen is 32. Why? Oxygen is one of our 7 diatomic atoms. If you had a bag full of oxygen as a gas, you would not have any you would really not have any individual oxygen atoms. They would all bond to form O2. So in chemistry textbooks, or when we talk about oxygen, we just say plain oxygen. We always mean O2. So it's assumed by oxygen, when you're getting the molar mass of oxygen, it's O2 when oxygen is by itself as a gas, because it's diatomic. So it's not 16 grams per mole, it's 32 grams per mole. Sulfur 32.07, that looks about right. And hydrogen, again, hydrogen is diatomic, so hydrogen's not going to be 1, it's going to be 2 grams per mole. So we got to be careful when we're working with gases. The 7 diatomic gases have no fear of ice, cold, bear. I think I got them all. 1, 2, 3, 4, 5, 6. No, we're missing one. Have no fear of ice, of, I don't know. Either way, hydrogen, nitrogen, fluorine, iodine, chlorine, bromine. I'm surely missing one somewhere in there. But, oxygen. Of oxygen. So those are our 7 diatomic gases. When we're working with them as a gas, we have to double the molar mass. So, concept check. How many atoms are there in a mole of gold atoms? How many atoms are there in a mole of silver atoms? So we have up here silver and gold, and I hope you realize these are irrelevant. The definition of a mole, if I said how many atoms are there in a dozen of gold, how many atoms are there in a dozen of silver? Well, the answer would be 12 in both cases, and because a mole is 6.022 times 10 to the 23rd units, a mole of gold and a mole of silver would have the same number of atoms. Of course, they would have a different atomic mass and a different molar mass, different weight. Density of gold and silver is definitely different. So if I asked you for 1 mole of iron, how would you do it? How would you give me a mole of iron? If I gave you a bag of iron filings, how would you give me a single mole of iron? Well, we know that 1 mole of iron weighs 55.85 grams. It's 55.85 grams per mole. So I think you would just get a scale and hand me 55.85 grams of iron. And how many atoms of iron would that be? Once again, this represents 1 mole of iron. 1 mole is Avogadro's number, 6.022 times 10 to the 23rd. And so we basically spent probably like 7 or 8 minutes just going over the idea of that special number and how to determine molar formula mass from the periodic table. Where we're going to go next in the next few videos, what if I asked you for 3.63 moles of iron? How would you give it to me? Well, hopefully you realize 1 mole is 55.85 and you need 3.63 of these, so you're going to kind of multiply these together. But we're going to learn how to do all sorts of conversions with moles, volume, atoms, grams, and so on. And also, what if I asked you for 3.63 moles of H2O? How do you get the molar mass of H2O? So that's where we're going in the future slides. This is Mr. Zapone. Hopefully you have an understanding of moles and how to determine molar mass based off the periodic table. Mole is 6.022 times 10 to the 23rd, and this number right here is the molar mass. I'm out.